Before we do anything else, I want you to think about the last time you gave your students a story problem. Did they look at it in defeat? They put their pencil down, kind of giving up already? Did they ask questions right away saying, I don't understand it? We need to start with kids learning how to think. And that's what we're going to do in this session, starting with activities that get students to think. Hi, I'm Mary Curry. I am the creator of Mango Math, and I have developed hundreds of activities for students to do. And I want to make math more accessible and enjoyable for kids. So we're going to start with our first game. Color Square is a logic and reasoning game, and it's a great one to get students to start thinking right off the bat. Very simple to do. You start with 3 colors, taking up 3 squares. And the only rules of this game is that no squares can touch each other just on a corner. So you can have them all touching on a line. I could have this one. I can't do it like this. I couldn't create one like this because the yellow is not touching the yellow. But if I had created one like this one, I can have the yellows are touching and the blues are touching. I cannot have it where I have the yellow here where it's just, there's no touching, only on the corners, it's not touching any sides. So that's the rule. There's 3 colors, 3 squares, and they have to touch on the sides. So I start this game with just a blank space. And then I ask the students to select any row or column that they want more information on. So let's say they ask it of this middle row. They ask it of this middle row, and I say that this middle row has 1 red, 1 blue, and 1 yellow. And I haven't put them in any particular order. So I asked the students, do they know what square has what color in it? And obviously they don't, because it could be, this one could be blue, this one could be red, this one can be yellow, or this one can be yellow, this one could be red, this one could be blue. So I want the kids to realize, and if they start guessing, I'm going to say, is that a guess or do we know for certain? And when they realize that they only are guessing, I'll ask, do you want more information? What would you like to ask for, another column or another row? So you get the students starting to think about what is a good route to go and what they where they should ask for more information. So you're getting kids to start to ask questions to get clarity. In this case, let's say they grabbed this middle, they wanted information on this middle column. And I say this middle column has 2 reds and 1 blue. Do you know what square has what color? And I let them sit and ponder this one for a while. And hopefully one of the students will come to the conclusion that this middle square has to be red. And the reason it has to be red is because we know that 2 squares have to be touching of the same color. So I can't have a red on the top and a red on the bottom. So this middle one has to be red. So we're going to give that a red color. My little scribble here. Do we know anything else yet? And you get the kids thinking about it. They don't. So then I have them ask, would you like more information? And if a student does not understand that why this one is red, I get them to explain it again. We talk through it. Now I get them to ask for another row or column. Let's say they go with this first column, and I say, and this one has 1 red and 2 blues. So I want them to think again, what are their options? What colors can go where? And hopefully they realize, because this one followed the rules that 2 reds, this middle one has to be red, that it follows that same rule for this blue one. Even though they're in different order, it follows that same rule. So we're going to color this one blue. So now I've revealed that I have 1 blue, 1 red. Now I get the students to start thinking about what else can be solved. So you start getting them to really start doing deductive reasoning and really deep level thinking, trying to come up with what goes where. And hopefully one of your students will realize that this last column, this middle one, has to be yellow, because it says there's 1 red, 1 blue, 1 yellow. So we've got that figured out. Then hopefully with all their thinking and the kids working together, that they'll realize they've got the information on what's in this column. They've got the information on what's in this column. What they don't know is they do then know that this column is going to be that yellow. So this one has 3 yellows to it. Let me get my blue marker here, or a black marker. 3 yellows. So now we're left with these last 4 squares and trying to figure out what they are. You ask the students, do you need more information? Hopefully they're going to say yes. Sometimes they'll talk back and forth and they'll start guessing again and say, well, I think those top ones are green and the bottom ones are blue. Well, are you guessing or do you know for sure? And so we talk about just guesses and reasonable guesses or certainty. And we don't know for certain which ones goes where. So then I give them that last clue and I say this one has 2 reds, 1 yellow. And so now the students know for certain that these top 2 are reds. So it's a great way for students to use deductive reasoning and start problem solving without the words and the story getting in the way. We're just using colors. You can then advance this up and you can do 4 colors, 4 of each color. You can even do 5 colors, 5 of each color. You can rate this up based on the student's skills. So just know that you have lots of options here to make it more difficult and more challenging for students. Now, if I wanted to take this one and start taking this idea of deductive reasoning and applying it to numbers, so we start using numbers, I can play the game, which is called Digit Place. So in this game, I will have a secret number that I do not show the students. And this is my secret number. And the students are going to guess a number, any 3-digit number that they want to. I normally do not repeat a digit, so I wouldn't have 2 3s or 2 7s in a number. I try to make them all different. Reason being, it might take a little bit longer. It just adds a little bit different dynamics to it. So let's say a student first guess is 736. That's the first guess they give. I'm going to tell them that they've got 1 digit. I'm not going to underline it, but you can see I have 1 digit in the right place. That means it's the right digit in the right place value. And then I have 1 that's just the right digit. It's not in the right place. So students should know if I have 1 place, 1 digit, they know they've got 2 numbers correct. And they know 1 of those 2 numbers is in the right place. So then they'll start thinking about it. Maybe the next guess will be 756. That wasn't a great guess on my part because I'm keeping 2 numbers in the same spots, but maybe that gave me more information in which I now have just 1 correct digit. So I know that hopefully students start to think about what they selected and where they've selected it. So this gets students really starting to think similar to that color code, but now with numbers. And we're starting to use the vocabulary we need about digits and place, columns and rows and so forth that are good math terms to get students to understand. And we're repeating that again and again. So you can set this up Once again, digit means it's the right number in the wrong place. Place means the right number in the right place. So we could play this game together. I'll try it with you, Ruby. Give me a number.
527.
527. Okay, so out of this number, 527, you have 0. There's nothing there.
All right.
So, oh, nope, sorry. That's my error. Oh, my error. You have 1 digit. So one of these numbers is correct, but not in the correct place. You want to take another guess?
Yeah, I'll do 739.
739. So good job selecting 2 new numbers. And out of that, you have 1 in the right place.
Okay. I'm gonna stick with my 7 in the front. I'm gonna do 748.
748. Good thinking, because you're doing new numbers every time. This one has 0 right.
All right.
So now we know 7's not in it, 4's not in it, 8's not in it.
Yes, and we know it's gonna be a 5, a 2, a 3, or a 9, or a 1, because I haven't said 1 yet. Let's do 135.
135 has 0 right.
All right, then what does that leave me? Okay. My 2's in the middle. Can you just put a 2 in the middle for me?
2 in the middle? All right.
Yeah. Oh, wait. Never mind. Scratch that. 9 at the end, 2 at the front. What number am I missing? A 6? 6 in the middle?
All right, you got 2 in the right place.
What number am I forgetting? Okay, I feel pretty good about my 2 and my 9, but what number am I? Okay. Do zeros exist in this?
Yes, zeros.
Okay, 209.
Great, you got it right. Good job. So one of the things, if you play this with just one other, you can get the students to really hone in on what the number could be. If you're playing it as a group of kids and they're all talking together, you're going to get more wild guesses and other students saying, wait, I don't think you should guess it. So you get a lot of really good discussion in this game, and you're really working on kids understanding what digits are, what numbers are digits, and then also place value. So a lot of good vocabulary comes into this. So when we start to add in story problems, we're starting to develop that vocabulary. All right, going on from there, getting them to think, doing thinking games. I'm going to do another thinking game, but this one I'm going to have them act it out. Acting it out is a great way to get kids to really get engaged with the game. So in this activity, I will have one child act as the farmer, have one child act as the chicken, one child acts as the fox, and one child acts as the grain, and they all play their parts. And you try to get them to work together to see how they can get all of these items across on a boat that can only take the farmer and one other thing. So the farmer can only take one item at a time across, and you have to get all these things across to the other side. Now the catch is you can't leave the fox with the chicken, or the fox will eat the chicken. You can't leave the chicken with the grain, or the chicken will eat the grain. So you have to think about, how do I get everybody across without them eating each other or eating the things that are there? So I have the students think about that and act it out. Once again, really starting to use vocabulary that's really good and helpful, asking good questions, and getting kids to work together to solve a problem. So in this case, the farmer can go across and take the chicken over, and then he can come back himself. Do I have him? And he can come, so he can come back himself. Now he's going to take the fox next. You're going to say, well, he can't leave the fox with the chicken. He can't. He's going to take the fox across and he's going to bring back the chicken. So now he's brought back the chicken. And then he's going to take the grain across, leave that there, come back himself and grab the chicken. And he and all the items now have gotten across. So students have to really kind of think about how you work out that problem, because obviously people are going to think, oh, I can't leave this guy with this. And that idea of bringing something back isn't always intuitive. So you get kids to really start to think about that. Now, to spice this up and add some numbers to it, I just went on to AI, put in this problem and said, can you put in numbers for getting everybody across and making it exciting? So I gave AI some parameters and made it come up with a math problem that has numbers involved in it. So in this one, it's the leaky boat challenge. The farmer's boat has a small hole. Every time he rows across the river, water seeps in. If the boat fills with 20 buckets of water, it sinks. So the boat fills at different speeds depending on what he's carrying. Now, granted, the farmer is a little heavier than the rest of it, so I could have put a little more thought into how everything weighed out, but this is how AI did it. So kids might question that aspect of it, but it's still a fun one to figure out. So the farmer alone is 1 bucket. With grain, you add on 2 buckets. With a fox, you add on 3 buckets. And with a chicken, you add on 4 buckets. Can he get everyone across on the boat before the boat sinks? So you have to see, can I get everybody across and with the boat not filling up with more than 20 buckets of water? So you give those students that problem and they can sit down and figure out the math and go through that back and forth again and putting in all the numbers to figure out the mathematics of it. It's a really good challenge to do with kids. They enjoy it and they really get the excitement of it. I would put the kids into groups in order to do that, much like I did with the acting it out. We do the same thing with figuring out the buckets. So now the answer is the farmer with the chicken goes across, that's 4 buckets. The farmer goes back across, that's 1 bucket. The farmer with the fox goes across, that's 3 buckets. The chicken comes back. Remember, we've got to bring that chicken back. That's 4 buckets. The farmer with the grain goes across, that's 3 buckets. The farmer comes back alone, that's 1 bucket. The farmer with the chicken goes across, that's 4 buckets again. And you add that all up, and that's 19 buckets. So he just made it prior to sinking. So it's just a really good way to get kids to start thinking through a problem and solving it. And we put in very minimal words, but we're still getting really good problem-solving skills. So is there any questions on any of these activities? Okay, so if we have no questions, make sure you check out Mango Math. We have a series of really good adventure problems, which are story problems, which the kids can solve and go work in groups to solve escape routes, much like these are, in which they have to really start thinking about how math is used and how to problem solve. So make sure you check out our website. We'll have it at the end of this video, and you can learn more about what we do here at Mango Math. Enjoy math.